Welcome back, chemistry fans. Today, we are going to be doing the Hess's Law laboratory. In this laboratory, we're going to have 3 different reactions, but 2 of them are going to add up to the third one. So it's just like the math problems we've been doing in class, except this time, we're actually going to see and be able to measure that heat that's going on with it. All right, so let's jump right into it. All right, so as you can see from the reactions that we are going to do, the first reaction is going to be sodium hydroxide, and it's just simply going to ionize, dissociate into the sodium and hydroxide ions. We're going to do that by adding 100 milliliters of water and 2 grams of sodium hydroxide. We will measure the temperature before and after the sodium hydroxide is added. Then we're going to do step 2. And in step 2, what we're going to see is then the sodium hydroxide is going to be added to the hydrogen chloride, the acid, and we're going to neutralize, and we are going to make salt as the byproduct. But in this process, we're going to see some temperature change. So we start with 100 milliliters of the HCl, 1 molar, and then 50 milliliters of 1 molar NaOH. We add them together. So reaction number 1 plus reaction number 2 is going to end up making our final reaction down here, third one. Sodium hydroxide is going to, again, combine with HCl, but this time we're going to use different concentrations. We're going to use 0.5 molar HCl, record the temperature, then add 2 grams of the sodium hydroxide solid. Record the temperature. Data analysis for this. We're going to end up using our heat formula, mass times specific heat times change of temperature. So we're going to do that for all 3 of the reactions. And then what we have to do here, though, is divide each of them by 0.05 the moles of NaOH, and that will then allow us to have a per gram amount. And then we're going to add 2 and 3, and hopefully it ends up being what is on step 3. So we'll try this out with the math here in just a second. But in the meantime, let's jump into what we have for the reactions itself in the laboratory. Okay, so here is my laboratory station that we're going to be using today. And so let's put this, let's put the camera over here so it's a little bit better view. There we go. And so now you can see what we're working with to get this experiment together. So if we follow those instructions, we're going to start with our calorimeter. We have used this before. And what we're going to add to that is 100 milliliters of water. I have pre-measured that 100 milliliters of water in these 2 containers. So we're going to pour those into our calorimeter. It was empty before. We've got 100 milliliters of water in there. That is just basically room temperature water. I'm going to put my lid on here, and I am going to then insert my thermometer in here. I've got my, let's see, how do we get this in here? Here we go. So we're going to put that in here. And so we'll wait just a little while for this water to come to equilibrium. And then we can get a recording of the first temperature here. And it looks like it's going down somewhere around 19.8. It looks like it's stabilizing. No, it went down to 19.7. That looks like that's where it's going to, well, 19.6. All right, so we're going to go with 19.6 as my starting temperature. Okay, now part 2 is I'm going to put 2 grams of sodium hydroxide into this container, and then we'll wait 1 minute and we'll see what the temperature ends up being. So here is my balance. I'm going to turn it on, and by leaving the container on here, the weighing boat, that's going to allow us to get the, that's going to allow us to have the, I'm trying to get it where you can see the, oh yeah, you can see it there. The weight not included, so it's been torn off there. And so we only need 2 grams of the sodium hydroxide solid, the NaOH. All right, so there we go. We're putting those in there. These little pellets, don't touch them. They're dangerous. They're caustic to our skin. They will cause us to irritate, so we'll need to wipe it off if we accidentally touch those. And we're at 4 grams already, so that's too much. Just a few pellets would get us there. 2.28, so let's take off 1 more. 1.93, that's pretty close. That's pretty close to 2 grams, so we're pretty much there. All right, so we got our 2 grams. So we're going to put our 2 grams into the water, into what we just did. We're going to put our lid on, and we're going to stir it around and we're going to wait for this temperature to get up to the maximum that it can, the maximum change that it can. So as we put that in there, I am going to use this little, there's a little knob right here that I can lift up and down, and that causes stirring inside of here without lifting the lid, without letting all the heat escape. However, that doesn't seem to be the case. It seems to have gotten stuck. There we go. Now it seems like it's going to mix. We'll wait 1 minute. I'm going to do time-lapse photography on this one to get to the final temperature. All right, through time-lapse photography, we were at 24.0, and I just missed getting to the button. Oh, there it's going up. There it is, 24.0. Good. So that's going to be the maximum temperature. 24.1 it went up to. 2. All right. Does it look stable? It looks pretty stable. All right, so that's what we're going to go with, is 24.2 as our maximum temperature on the first reaction. Okay, I'm going to pause the video, clean out my container here, and we will start on experiment 2. Okay, so as a reminder, first reaction we just completed, that was the NaOH in the water. Now the second, what we're going to do is we're going to put 1 molar HCl and 1 molar NaOH together and figure out what the temperature is going to be. So let's jump into that part of the experiment. So we have our calorimeter again, and we're going to take the temperature after we put in 100 milliliters of HCl. So this is our 1 molar HCl. I have pre-measured my container for 100 milliliters of that. So I'm pouring both of those in there simultaneously for this one. We are going to put the lid on, and we will let this reach its equilibrium as well. So let's find out what's the starting temperature of this portion of it. It shouldn't be too different from where we started with the water. It may be a little higher. We'll see. So it looks like it's going to hit equilibrium here at about 21 also, maybe. Let's see if it hits it. 20.9. Nope, it did hit 21.0. Okay, so that's where we're going to take it. Now, what I'm going to do next is I'm going to pour in 50 milliliters of 1 molar NaOH. 50 milliliters, again, pre-measured it. So I'm going to lift the lid. I'm going to wait 1 minute. I'm going to add this to it, and we're going to see what happens to the temperature after I have added this to it. So already you can see the temperature starting to go up a little bit. So I'm going to pause this, and we'll see how high it gets, and we'll come back to you. All right, it looks like we have stabilized now. We are up at 26 degrees even. So these numbers are coming out nice and round for me. Easy subtraction I could do in my head. All right, so that is going to be the end of part 2. Let's now jump back and see what part 3 has in store for us. This is the third reaction. So in the third reaction, what we're going to do is we're going to repeat a similar process before. We're going to start with HCl, but this time 0.5 molar. 100 milliliters, and add 2 grams of the NaOH. We hope that reaction 1 plus reaction 2 will equal reaction 3. We will find out. So let me pause, clean up, and I will be right back. Okay, back to part 3. So in this part 3, what we are going to do is we are going to add a pre-measured amount of 0.5 molar HCl. So we're going to pour both of these into here to make 100 milliliters of 0.5 molar HCl. So I've got 100 mils in there. Let's take our initial temperature of this to see where we start, and then we will go from there to figure out where it ends. So here, let me move you out of the way. Right over here. There we go. And let's see about getting that. There we go. That glare off there. So 21.6. Looks like that's going to be my stabilizing starting temperature for this third reaction. Doesn't seem to be changing. All right. Next, we're going to add then the solid NaOH. We're going to add the solid NaOH. I have pre-measured 2 grams of these pellets. So I'm going to add those in. And we will then wait 1 minute. I'm going to do time elapsed. And we are going to see how the temperature changes as we move forward, as it dissolves. All right, it looks like it's come almost to the end of its reaction, about 30 degrees Celsius. It's going up very, very slightly, so it may hit 30.2 here, but it looks like it's slowing down. There it goes. Okay, so we're going to take those as our final temperatures now. So I'm going to take this away. Oh, 30 point, no, it went back down to 30.3. Yeah, 30.3. We'll let that be the final temperature. Okay, now here we go. Here are all of our data points that we just collected. So we are going to go ahead and convert these into delta T's. So 24.2 minus 19.6. I'm doing this on my calculator right here. So my delta T right here is 4.6. This is 5. And this went up actually to 30.4 the last seconds I was unplugging it. This is 8.8. Now, roughly, those two are supposed to equal this one. Now, it's not temperature. Temperature is not necessarily summative in this case, but it's going to be close. You notice they're pretty close, 9.6, 8.8. We're pretty close there. So our error is not going to be too bad off. All right, so let's calculate some heat values here for each one of these. Let's go back to the workload here so we can share our screen and see what we are doing with the math portion. All right. So here it is. So our heat value will be the 100 grams of water. That's the basis for all the solutions times the temperature change times the specific heat of water, and then divide all of those values by 0.05 moles. That's how many moles of sodium hydroxide we had in each, 0.05. All right, so stop sharing. So let's do some calculations. So what was it? 100 for the water, 4.18 times the temperature change, 4.6. 100 times 4.18 times 5, and 100 times 4.18 times 8.8. And then divide by 0.05. So 100 times 4.18 times 4.6 divided by 0.05, 38,456. 100 times 4.18 times 5 divided by 0.05. And 4180. 100 times 4.18 times 8.8 divided by 0.05. Try that again. 3678.4 divided by 0.5. 73,568. All right, so if I were to add together these two, 38,456 plus 41,800, I get 80,256 as my joules. So I could divide that by 1,000 and it would be 80 kilojoules. So what we got there is 80, but that is the laboratory value. So we'll subtract that from 73,568 divided by 73,568, and we'll get our percent error. So we'll take that minus 73,568. Oops, try that again. 80,256 minus 73,568 divided by 73,568. And what we get is a very respectable 9% error. 9.1% error. That's not bad for a little simple lab that we just performed here. So, oh, you can't see all my math work down there. Sorry, there's my math work for the last portions of it. That's my percent error calculation. All right, so let's see, where are we? Let's go back to a different camera and I will say my fond farewells. Thank you very much. This is the end of the Hess's Law. I hope that you understand it a little bit better and relate it back to something more practical, an actual lab. Thank you very much. Have a great day. Bye-bye.